So topics for today's class is solution to separable differential equation. Solution to separable differential equation. So first of all, what is differential equation? So differential, here are some examples. So differential equation means it's an equation that involves the derivative, okay? Sometimes the first order derivative, it involves first order. In this case, there is this third order derivative, okay? And sometimes the partial derivative involves in the equation. So these kind of equations are called differential equation. And there are two kind of differential equation. One is called the ordinary differential equation, another partial differential equation. Ordinary differential equation is the equation of this type, first and second, where we have dy over dx. What it means is we are talking about function of one variable. Okay, so something like y equals f of x. So function of one variable. Now the partial differential equation involves partial derivative. So partial derivative, we will talk about this in the next module in detail. So partial derivative means it involves the function of two or more variables, okay? So something like z equals function of x and y, okay? So in this course, we will focus our attention on ordinary differential equation only. First order ordinary differential equation. So this partial differential equation, we will not do this in this course. This kind of equation, we will not do it, okay? And now the first concept that we'll be talking about is separable. Remember, the topic of this lesson is separable differential equation. So we now know that differential equation is the equation that involves the derivative. Now, what is separable? Separable means you can separate one variable, let's say x and dx one side and y and dy another side. Let us look at example 1. In part A, so dy over dx is given 12x to the power 5 plus square root x plus e to the 5x. Clearly, this is an equation and this is a differential equation because this equation has derivative. Okay. Now, the first thing, when you try to solve the differential equation, the first thing you ask yourself is that, can we separate y and dy one side of the equation, x and dx to the other side of the equation, x, dx, and other numbers? That's the first questions you will ask yourself, okay? So in this case, what I'm gonna do is, with simple high school algebra, I think you already know, you just do the manipulation here. So you can get 12x to the power 5 plus x to the power half plus e to the 5x dx. We can write this way, right? So simple manipulation of this. So rewrite this way. Rewriting the equation, or separating y dy one side, x dx to the other side. That's why it is called separable differential equation. It's easily separable. But there are some other differential equations where you cannot separate x and y into two different sides of the equation. And in those situations, we will learn a different technique to solve. So right now, we focus our attention on the type of differential equations where we can separate x and y, x dx, one side, y dy to the other side. Now, our goal is to find the, function, okay? our goal is to find the function y equals something. So what we're going to do is, second step is to integrate both sides. Integrating both sides, we can write dy equals integration 12x to the power 5 plus x to the power half plus e to the 5x dx. That's your second step. Step number 1, separate. Step number 2, integrate. Step number 3, now you know how to integrate this, right? So the integration of dy is simply y plus c, but I'm not going to write c on this side because I think we already know y, because we just write c at the end. So y equals, this guy will be 12x power 6 over 6 plus x. This will be half plus 1, which is 3 over 2 over 3 over 2 plus integration of this e to the 5x will be e to the 5x over 5 and plus c. That's it. We're done. This looks a little ugly, so let us put it in a nice form. You can write 2x to the power 6 plus, this will be, when you flip it, you're going to get 2 over 3 x 3 over 2 plus 1 over 5 e to the 5x plus c. This is the solution. And this kind of solution is called general solutions, okay? This is the general solution for the given differential equation. Remember, there are two kinds of solution. One is called general. So this is the general solution. And we'll talk about the particular solution in a minute. In a particular solution, what happens is that they will give us an initial value condition so that we'll be able to find the exact value of c, and we'll put that value back. And that kind of solution is called particular solution. It's coming up, so don't worry. Do you have any questions? If you don't have any questions, I want you to try part B right now, just for fun, okay? So dy over dx equals y over x. Step 1, separate y dy one side and x dx to the other side. Okay, in step 1, we try to separate y dy one side, x dx another side. That's what we did. And in step 2, you integrate both sides. And you know the integration of the left-hand side is ln y equals, on the right-hand side, we'll get ln x plus c. We kind of done actually the differential equation is, you know, there is no more derivative involved, but it looks ugly. Generally, we need to find the solution in this form, y equals, you know, function of x in that form. So we don't need that, we don't want that long. So what you're going to do is now recall from your high school. Exponentiating both sides, you can get e ln y equals e ln x plus c, right? So recall from your high school that e ln x equals simply x. Remember the formula, logarithmic formula from high school, okay? We know this formula. So using that formula, you're gonna get y equals, you can write this as x plus c. right? Okay. Or you can do this way too. Another way to do this would be, anyway, hold a second. We can simply do this way. I think the easier way is to do this way, okay? Instead of that, let us do a little bit of a high school calculation. We'll do this way. First, we combine the logarithm together. So that's going to give me ln y minus ln x equals c, okay? To make calculation easy, it's all about, the pre-calculus algebra now. So then we can write this ln y over x equals c. Remember, we know the formula, ln x minus ln y, or ln y minus ln x equals ln y over x. We know this formula before, right? So using that formula, you can write this. Now you exponentiate. Taking e both sides, you're going to get e ln y over x equals ec. And so that's going to give me y over x equals e to the c. So that's going to give me y over x. Because to remove the absolute value sign, you may want to write this as positive and negative ec. By the way, yeah, let's write ec. And so your y value will be, now you can simply multiply that, right? So it's plus minus ecx. Any questions so far? Or you can write y equals kx, where k equals positive, negative e to the c. You can do this way too. Okay? Any question? So part C, we are given dy over dx equals cosine 5x. So the first step is dy equals cosine 5x dx. Now you integrate both sides. So this guy will be y equals, so integration of cosine is positive sine 5x over 5. Remember, integration of cosine 5x dx, the formula is, cosine will be sine positive, by the way. Sine 5x over 5, we know that. So plus c, that's it, done. Part B looks interesting. Let's try part D. By the way, these are general solutions, okay? When there is C involves or some constant involves and you don't know the exact value of the constant, we call it a general solution. So this is the general solution, okay? Now let's try part D. This part D looks interesting, and let's try it just for fun again. When you are given this y prime, I suggest you change it into dy, because that makes life easy later on. So dy over dx equals x, you can take common, so 1 minus y. And now try to separate them, okay? Y dy one side and x dx to the other side, and yeah, and then integrate. And let me know what is the answer. So recall that integration of dy over 1 minus y will be negative ln 1 minus y, because you already, I believe you memorized the formula. We prove it using the substitution rule before. So if we are given integration of 1 over b plus ax, for example, dx, then the integration formula will be 1 over a ln b plus ax. This is the formula that we talked before, and you may want to use that formula to save time. Otherwise, in order to evaluate the integration of this, you can also use the substitution rule, okay? Let us suppose that u equals 1 minus y, and then your du will be negative dy, and then you can substitute the value. You can find it out yourself. I trust you guys, you will be able to do it. And yeah, somebody already got the answer in the chat box. Thank you so much. And after this is basically high school, pre-calculus concept. The integration is done, okay? You just simplify and write in the nice form. Generally, we will be getting the solution in the form of y equals something, if possible. Sometimes if changing into y is really complicated, then we don't do it. We just leave it like that. But in this case, it's not that difficult. So we'll do the, pre-calculus. We use that knowledge that we learn in pre-calculus and simplify a little bit further, okay? Again, using the high school formula that you learn in high school, we can write e to the a plus b as e to the a times e to the b. So we're going to get this. And if I want to do this 1 minus y, if I want to get rid of the absolute value sign, I must write positive and negative there. And let me write e negative c there. I'm going to get e negative x squared over 2. Okay. So then negative y equals, I subtract 1 both sides. I'm going to get k e to the, or let me do this way. Negative y equals positive negative e to the negative c and e to the negative x squared over 2 minus 1, okay? See here, this 1 is there, so I subtract 1 both sides, that's what I'm going to get. Or minus 1 you can write here, doesn't matter. Now y equals, you're going to get negative positive e to the negative c, e to the negative x squared over 2, and that will be positive 1. Okay, that's the answer. But you see, this looks a little ugly. After all, this is a constant. So to make things look better, you can substitute that as k. K e to the negative x squared over 2 plus 1, where k equals e to negative positive e to the negative c. That's it. Okay, this is your general solution. Any question, guys, so far? So far we talk about general solutions, okay, in each and every questions. Now let's look at particular solution. What does that mean? How do we find particular solution? Okay, so let's go to example 2. In example 2, find the particular solution for the initial value problem. Let's begin with part A. So given, again, when they give you derivative in this form or in y prime form or f prime of x form, personally I find it easy to change that into dy over dx. Okay, and then we can separate dy equals e to the x plus 5x minus x power half dx. Okay, again, we are able to separate them. So now the second step is integration. So integration of dy is simply y. Integration of e to the x is e to the x plus 5x squared over 2 minus x 3 over 2, and this is 3 over 2, but if I flip it, I'm going to get 2 over 3 plus c. This is called a general solution. Now, in this example 2, one extra thing is given. This f of 0 equals 8. We call this initial value condition. Okay, so initial value condition is given. Given initial value condition as f of 0 equals 8. What does that mean? F of 0, or you can say y of 0, doesn't matter. We change that f of 0 into, you can also write y of 0 if you like. Y of 0 equals 8. What it means is when x equal to 0, y equals to 8. That's the meaning of that, right? Now substitute this value in the general equation. Substituting or using this initial value condition, then what you can do here is y equals 8 equals e to the x is 0 plus 5 over 2 0 square minus 2 over 3 0 raised to power 3 over 2. Now plus c, there is c, and you simplify it and let me know what you get. On the left hand side you have 8. On the right hand side, e raised to power 0 is 1 plus 0. This is also 0 plus c. Okay, simply 1 plus c. So this is going to give me c equals 7. Okay, now substituting value of c equals 7 in general solution. So we get, what we get is y equals e to the x plus 5 over 2x squared minus 2 over 3x 3 over 2, and plus c is 7. This is called particular solution. Okay, this is called particular solution. Any question? So if you have any question, let me know. Otherwise, I want you to try part B right now just for fun. So you can write this as, let's say y square equals negative x squared plus k, where k equals 2c, and you can write y equals positive and negative x squared plus k. So that's one way of writing this. Or what you can do is, let me write this way from here, or you can write the answer as y square plus x square equals 2c, and y square plus x square equals maybe m square, or maybe k square. Okay, some constant, let's say a square, for example, or r square, where a square equal to c. So you can write in this form as well. Okay, either this form doesn't matter. Okay, now let's try the last question for this section. In example 3, I trust that you can do this by yourself. Think for a second how we can prove that y equals 4e to the x plus 5e to the 3x is a solution of this differential equation. We need to prove that this is the solution for this.
It means we will solve that equation and then put a y value in that. If both the left and right hand side is equals to 0, then it is a solution of that.
Excellent. Okay, guys, try this, everyone. Remember, in high school, for example, if you are given 2x plus 3 equals, let's say, 7, okay? And suppose this is the equation, and to check, is x equals 1 a solution? If you want to check this, whether x equals 1 is a solution or not, what you're going to do is you can put this value there, right? So 2 times 1 plus 3 equals 7. No, that's not true. So that is not a solution, okay? This doesn't check. So x equals 1 is not a solution. So we know this. We're going to use the same technique here to prove. Okay, guys, go ahead and try. So in example 3, I trust that you have already done it, but let's look at this quickly. We want to prove that this one is the solution. So what is given here is we are given y equals 4e to the x plus 5e to the 3x. Now you need to find the first derivative. Let me find the first derivative and then find the second derivative. First derivative will be 4e to the x plus second derivative will be 15e to the 3x. Now find the derivative of this again, which means derivative of 4e to the x will be 4e to the x plus derivative of this guy will be plus 45e to the 3x. Okay, I trust that everybody know how to find the derivative, and you have done that in your calculus 1. Okay, now substituting this value in the equation, substituting values of y, y prime, and y double prime in the given equation, which is y double prime minus 4y, let me just write here, y double prime minus 4y prime plus 3y. In this, what do we get? Okay, so we'll get y double prime is 4e to the x plus 45e to the 3x minus 4, and y prime is 4e to the x plus 15e to the 3x plus 3y. Y means 4e to the x plus 5e to the 3x equals 0. So all we need to do is left side and right side are equal. That's what we need to prove. Now let us do the calculation here. 4e to the x plus 45e to the 3x minus 16e to the x minus 60e to the 3x plus 12e to the x plus 15e to the 3x equals 0. Now let us combine the like terms. So 4ex and 12ex will be 16, positive 16e to the x and negative 16e to the x cancel out. Now let's combine the other term. So e to the 3x, e to the 3x. So these three terms are like terms. So 45e to the 3x plus 15e to the 3x will be 60e to the 3x, positive and negative cancel out. So we got 0 equals 0. So yes, okay, proved. Therefore, you can write that hence y equals 4e to the x plus 5e to the 3x is the solution of y double prime minus 4y prime plus 3y equals 0. Okay, that's how we're gonna do it. Any question? Okay, now in the next section we will be working on linear first order differential equation.